Well, welcome everybody. Looks like we've got a packed house. Um, Happy to have you all here. And today's topic is maybe a little bit less flashy, but nonetheless very important, which is on evaluation. Um, since we have so many people here, I'm probably going to refrain from taking questions. I think we have, what does it look like, 72 people right now. I'd say I'm going to hold off on taking questions as we go, and we'll leave some time at the end to do dedicated Q&A. Yeah, so if all that sounds good, we'll go ahead and get started here. So we actually have a lot of content for this topic. It's pretty broad. And so we decided to actually break it up into two separate sessions. The first of which is today, where we'll focus a lot on just like a high level broad introduction to the topic of evaluation as it pertains to LLMs. So why is it important? Why is it particularly challenging versus evaluation in the context of traditional machine learning? And then most of the time will be spent walking through what methods do we actually have available today to evaluate LLMs. And then what that allows us to do is dedicate another full session to like a more practical, more hands-on view of evaluation, which is like, how do you evaluate LLM systems on your own data? So we'll have like a hands-on example, walkthrough of that, and we'll also throw in some considerations for how you deal with hallucinations, techniques to mitigate and overcome that. Cool. Awesome. So that's the agenda. We've got a lot to cover, so we'll go ahead and get started here. So first off, why is evaluation important? I think we all recognize that evaluating any type of production system is important, but why, especially with LLMs? And so I guess the first thing to kind of recognize is that, like, especially with LLMs and this field of generative AI, it's never really been easier to get started. Previously, to do machine learning, you had to have some background in machine learning. You had to understand how models worked, how to collect the data set, how to train it for very specific tasks. And nowadays, like LLMs are these general purpose reasoning engines, and you have developers, software engineers, front-end engineers, all these people who understand how to code, just hooking in and using an API to do machine learning. And that's great. Like, I think the more people that can get value out of this, the better. But there used to be a rigor to how things were actually built that I think is getting a little bit lost today. And so I think this meme captures it well, where you have like some frustrated data scientist who gets tasked with, their manager tasks them with, I don't know, building some question answering system over PDFs, or maybe generating some natural language to SQL queries. They go out and Google, and all of a sudden, oh, there's a template that does exactly what I want. LangChain has exactly what I need. And pretty quickly, like, you realize that LangChain is great. Don't get me wrong. It's a fantastic set of resources, but LangChain templates only get you so far. The performance you see on a simple demo example in a LangChain template is pretty quickly going to fall apart when you actually go to try to apply that to a real world use case. And I'm sure many of you who are building and experimenting have noticed this. Nothing against LangChain, love LangChain, but this is just the truth. Like, this is the way things work. There's a lot more that goes into building a production system than just a demo example. And so when you start to move towards this idea of building a production system, like, yes, the example from the template may have worked, but as soon as you start to expand outside of that, like, you start asking these questions about, okay, like, I see that I changed things a little bit, or I have a slightly more complicated example, and all of a sudden it falls apart. And so that begs the question of, like, okay, well, where is my system, and when is my system actually working? When and where is it not working? When is it failing? Which use cases can it handle? And then, like, the better question is, like, how do I even know? Like, is it possible for me to test for these things, to have a broad understanding of where things are performing well and poorly? So I guess, yeah, some of the reasons why LLMs are particularly difficult in production, I guess, first of all, is, like, this is a new unestablished technology. LLMs themselves are, like, I don't know, a year and a half, 2 years from prime time. And there's also a lot of moving parts to them. most applications include data pipelines and idea of like retrieval. So there's a lot going on. And I guess specifically for LLMs, you have this idea that models are constantly changing. So if you're likely building an like an LLM application, chances are you're probably using some type of like AI as a service. So be it OpenAI models or Anthropic models, whatever it may be. The model that sits behind that endpoint is likely changing. There's updates to it. There's improvements. And so like you get to this point where you're like building your system on a foundation that is a little bit non-fixed. It's moving, which introduces a whole set of challenges of itself. And then even if you are like building with open source models, each open source model has completely different performance characteristics. It's trained on different data. It's trained with different methodology. And so there's not really a ton of consistency there. There's also updates to those. Second reason, LLMs are prone to errors. I think we all know this. Anybody that's worked with them for more than 10 minutes understands that they often fail to follow instructions. There are tons of logical inconsistencies. It's hard to get them to output the right format when needed. Toxicity or the wrong tone of voice can be a problem, or more recently, so the opposite, where LLMs are so cautious that they fail to actually provide a helpful answer. And then things like obviously like hallucinations, like LLMs are very good at confidently telling you something that is just completely wrong. I guess the final reason here is this idea that like when you try to make improvements to a system, be it through prompting or fine tuning a little bit to try to like correct some issue that you've noticed, improvements in one area often result in performance degradations in another area. And so I've often found like as I'm building systems, it's a bit like whack-a-mole where I see this issue, I change my prompt for it, it satisfies that issue, but then there's regressions in other areas. So for all these reasons, evaluation is important and difficult. And so I guess like how does an evaluation framework help? Well, the main thing it does is it allows us to quantitatively measure how well our system or product is doing at any point in time. And therefore we can use that to detect regressions. So it gives us a way to like validate and ensure some level of performance and some level of risk before we ship a product, before we put something out to users. And then once that's out there, it allows us to, it's like an evaluation framework serves as like a common language that we can make decisions around. Like if we have this framework in place that's agreed upon, that we understand what it's measuring and how, it allows us to test changes and all agree upon, hey, this delta in performance is something we can rely on, and we can make decisions around that faster. And then, yeah, I guess the final thing is like identifying areas for improvement. You don't know what you don't measure. And so if you have at least some evaluation framework out there, you can target, hey, this is where we're underperforming. Let's prioritize this as something we can improve. So the TLDR on this, or the takeaway is like having a representative set of evaluations, evaluation metrics or evaluation suite brings us a step closer towards reliably measuring system changes at scale. And if you aren't able to do this and you have a system in production, you really are just flying blind. Like you don't know what's going on and where you're performing well and where you're performing poorly. Yeah. Okay. Last thing on this is it really, I guess like the take home message is that like why is evaluation important? Well, at the end of the day, it helps us to build trust. So from the people that are building AI systems, we have trust that our system is going to perform to some level. We have trust that we understand the risks to some level of what it means to put this system into production. And from our user standpoint, it gives our users trust that they can rely on the answers that we have. I don't know about you, but like it's very often that I'll be using ChatGPT or whatever model, and I get an answer and then go straight over to Google and ask the same thing to try to double check it. And so having evaluation in place or some robust means of evaluation just builds trust for everybody involved. Okay. The next part is, so why is LLM evaluation particularly challenging? And I mean, particularly as it relates to, in contrast to traditional machine learning. So I guess like the first thing to note here is like this idea of evaluating ML models is not new. This field of ML has been around for a while. We have strong practices in doing so. But one important thing to point out is that like this field of generative machine learning, generative AI, is very different from traditional discriminative machine learning. And so I guess it's worth unpacking that a little bit first. So in discriminative machine learning, really the focus there is on learning some conditional probability distribution of some ground truth labels given some input data. So this idea that like we're trying to learn the ability to separate out a boundary, or there's some ground truth where we can clearly demarcate truth or like correctness from failure. Like we clearly know that a prediction is correct if it's on this side of a boundary line. Versus in generative AI or generative machine learning, we don't really have that target. We don't really have those labels. It's more about learning the underlying data distribution itself. So learning the underlying patterns that are inherent to the data, such that we could then use those patterns to reliably produce a new sample that's consistent with the rest of the data. And so this is an important distinction because it has a lot of downstream impacts on evaluation. Like in particular, this idea of like a lack of an objective ground truth, like we lack the ability to say, is this on the left or right side of the line? And because we lack that, we therefore have unreliable metrics or less reliable metrics to actually quantify performance. And so I guess that's a little bit high level theoretical. To make that a bit clearer, we can look at an example. So discriminative machine learning is this here, where we have pictures of muffins and chihuahuas, and we clearly have ground truth labels of what they are. And we also see that we can get predictions from our model that can easily be compared directly against the label to see if there's an error or not. And we can then total up those errors with whatever metric we care about. And this gives us some like objective measure of performance of our model given this labeled data set. However, in the world of generative machine learning, we don't really have these clear quantifiable metrics. So here we have like images of a sheepdog, and the task is image captioning. So we are generating a description of this image, and our label here is photo of a sheepdog. And our model went and predicted that this is a dog that looks like a mop. Well, I mean, first of all, like this prediction, while it doesn't match exactly the label, it's not necessarily wrong. Like I would argue that this is a dog that looks like a mop. And I would also argue that there is some overlap with the label, but it's not clear how we measure that. Like what does it mean for this prediction to be correct? Is it that it's exactly what the label said? Well, that doesn't make sense because there's some version of this that could be slightly off, but still be largely correct. And so you see pretty quickly here how this notion of like objective ground truth goes by the wayside when we have multiple possible ground truths. And that leads you to like the next question of like, okay, well, what does it mean, or what makes a piece of generated text quote unquote good? Like what does that actually look like? And so if I ask GPT-4 the same question twice, what makes a piece of generated text good? I get two completely different answers. One that's a bit shorter, has 3 unique bullet points. Another that's a bit longer and has 8. And like, I don't know, like which one of these is better? Well, it's really hard to say. And the reality is that it's in the eye of the beholder. Like it's a very subjective measure of like what is good, like what is a better piece of generated text. And so what we can do is like we can try to assign dimensions or attributes that we might want to quantify or that we care about. And so like maybe I as an individual care about my text generations to be accurate, to be well formatted, and to be concise, while somebody else might care about them being relevant and funny and truthful. And so it's like it really is subjective, but like let's take that as it is. It's going to be subjective regardless. Let's say we do pinpoint a few dimensions that we care about evaluating. So call it accuracy, formatting and conciseness, we then are faced with the question of, okay, how do we measure that? Like, what do we do to measure the creativity of a piece of generated text? It's not like we have an automated metric where we're just comparing against some ground truth. So for all these reasons, you see how difficult evaluation in this generative paradigm becomes. The second major reason why I'd say LLM evaluation is difficult is because there is a wide diversity of tasks that these LLMs can do. As I mentioned, they're general purpose reasoning machines. This is the first time we've had something like this in machine learning. And so you have this one model that can be used simultaneously to translate from English to Italian, answer factual questions about the governor of Illinois, give me suggestions on how to format my pandas data frame better, and creatively write me a poem. And so it's like there are all these use cases. And what that means is that the scope of what LLMs can actually do is far greater than the benchmarks that we have available to evaluate. And so I think this meme here sums it up nicely. Like the tip of the iceberg is the things that we actually can measure, things that we have evaluation data sets for, which is a small subset of things relative to the base of the iceberg, which is all the things that LLMs can actually do for us. And like in traditional machine learning, like we had these really narrow scoped data sets and tasks. And so we could pinpoint accuracy within a defined means. In this world of generative ML, there's just so many edge cases. There's so many like possible little points of failure. It's really hard to create evaluation data sets and metrics that capture all of the totality of the possible things that they can do. Yeah, and then I guess the last thing I'll say here is like, in general, our methods for evaluation they're just not mature enough yet. Like LLMs alone are a very nascent field, and evaluation of LLMs even more so a nascent field. And so in its current state, it feels a lot like this is more of an art than a science, which I think it kind of is. And it's well pointed out by this tweet from Andre Karpathy, which is, I pretty much only trust two LLM evals right now, Chatbot Arena, which we'll talk about in a little bit, and the local llama subreddit, which I also kind of agree with. And so I guess like to elucidate this a little bit, we see there's one paper that studied small changes in prompt format can result in wildly different evaluation scores. So if you were to like pass in, you were to format your prompt like this, where you have a passage, space, some text, and answer, space, some text, and you ran your evaluations, you would see that this data set of answers gets, call it 75% of an performance evaluation score. However, if you make one slight change, which is just to remove the space between the text and the passage, the colon, that same exact set of questions and answers gets now scores 3.6%. And further, if we get rid of the line break and we just use a space to delineate them, we get up to an 80% evaluation score. And so it's like our methods are very finicky. Like this begs the question, are we measuring the right thing? Like are we measuring what we think we're measuring, or are we measuring subtle changes to the prompt structure that are actually causing wild variability in our outcomes? And another thing that kind of points at like the immaturity is like, there's this other study that found like, if you ask an LLM a question and you say, I'm going to tip you $300,000, it leads to a much higher quality response than just asking the question alone, which is ridiculous. And like, it again hints at the immaturity and like how finicky some of our evaluation techniques are, and our means for evaluation. Okay, so I just got done describing why evaluation is important and why our current methods are terrible. which is a little bit hopeless. And so I guess the question then is like, we understand evaluation is important. We have to do it. What options do we have available to us? Like what is in our arsenal? And so I would argue that there's um, four main like groupings of ways that LLMs can be evaluated today, are evaluated today. And those are the use of public benchmarks, which I think everybody's probably seen in some form, and we'll dive into. This idea of functional correctness, which itself is kind of a subset of a public benchmark, but is slightly different and I think warrants its own bucket, which we'll talk about. Human evaluation, which I think everybody's probably familiar with. And then model-based evaluation, which is an area that I think is probably the most exciting and promising, and therefore has a lot of attention nowadays. So we'll spend some time talking about that as well. Okay, so public benchmarks. So I know myself included, I've seen, you see reports all the time on social media or wherever that like X model is now percentage points better than this previous model on so-and-so benchmark. And it's like, you just kind of take it at surface level for what it is. And you're like, oh, all right, it's better. But there is a lot of nuance underneath what that means. And the point of this section is hopefully to demystify that a little bit, to give you a better view into like what we're actually evaluating in some of these public benchmarks and some of the faults that might occur, why maybe they shouldn't be trusted as much as they are. But nonetheless, the first thing to know about public benchmarks is that there are a lot of them and that they vary in quality as well as like the task or the specific domain that they're trying to measure. And so here on the left, we see like this is just a list of 46 of the more popular ones. There realistically are like hundreds of benchmarks out there. I don't even know how many. But things like you've probably heard of MMLU, Chatbot Arena, Alpaca Eval, Helm, Big Bench, Glue, these kinds of things. Like, you've probably heard some of these, but maybe don't know exactly what they are under the hood. So we'll look at a couple of them here to hopefully try to explain that a little bit. The second thing to know about benchmarks is that for a lot of them, they're actually further subdivided into lots of tasks. So for example, MMLU, which is a very popular standard benchmark, has 57 subtasks within it. So it's not like each one of these benchmarks is just like its own atomic thing. They often are further broken down, making them even more confusing. And we'll talk specifically about MMLU in a second. The second, or I guess the third thing to know about public benchmarks is that they are often combined or like curated into collections to form what we know as like leaderboards or test suites. So a good example of this is like the Open LLM leaderboard, which I think a lot of people are probably familiar with, which is a leaderboard that we host. It's actually a leaderboard that's comprised of 6 different benchmarks here. So 6 different individual benchmarks that get averaged together to have our Open LLM leaderboard score. So like an aggregate measure of performance over 6 selected benchmarks. And this is a common theme. It's not just us or Open LLM leaderboard, but like Helm is another popular one of these, the Eleuther AI eval harness, or the Mosaic ML gauntlet. And so for example, what we see here is for Mosaic, they basically decided, hey, there's these 6 major buckets of things that we like, major topics that we want to evaluate. We determine are important to evaluate an LLM's competency. And so for them, that's like common sense reasoning, programming, world knowledge, these types of things. And what they do is they then go and select individual benchmarks to fold underneath that umbrella of the topic. And so what you can then do is like when a new model comes out, you run it across all these benchmarks, you aggregate the scores, and now you have like an easy like 6-way scoring reference to evaluate like comprehensively, here's how this model performs in common sense reasoning. And so hopefully that like breaks things down a little bit because it can be confusing. It's rarely the fact that you're ever like looking at just a benchmark score. It's often like an aggregate of benchmarks to try to get a broader understanding of an LLM's performance. Okay, so with that, let's take a look at a couple individual benchmarks. So the first one here is MMLU, which I've mentioned a few times now. It's called Measuring Massive Multitask Language Understanding. It came out in 2020, so it's a little bit old, but nonetheless, it's super popular. And so basically, like this benchmark is 14,000 question answering examples that are all in multiple choice format. And so you see like, suppose you live on the moon, how long is a day from sunrise to sunset? And you have 4 options, A, B, C, D. And the goal is to predict which of the 4 options is correct with a single letter output. Or things like, which of the following areas is not covered by the principles enshrined in the UN Global Compact? 4 options and a label. And these questions, these 14,000 questions, as I mentioned, are broken down across 57 tasks that span various amounts of world knowledge, everything from math to computer science, chemistry, biology, philosophy, all these different subsets of things that you might want a model to have broad understanding of. Another benchmark, just to share like the details of another benchmark, is GSM 8K, which is a grade school math data set. And so this is 8,000 grade school math word problems where the word problems themselves require multiple steps of reasoning to arrive at an answer. And the math behind them is just simple arithmetic. They can all be solved with simple addition, subtraction, multiplication, division. So just to give an example here, like one question is, Beth bakes 24 batches of cookies in a week. If these cookies are shared among 16 people equally, how many cookies does each person consume? So like a very simple question that like elementary school students should be able to reason through. But some of these are like multiple hops of logic and understanding like where the numbers correspond to which entities. And so you can see like wildly different benchmark than MMLU, but nonetheless like measure something completely different. And this is a standard benchmark that's also included in Hugging Face's leaderboard. Okay, so that's just 2 examples. We'll move on to talk about some issues with public benchmarks, of which there are many. The first I would say is this idea of like inconsistent reporting of results. And so a good example of this, and this happens everywhere. This isn't just me picking on Google here, but I'm going to pick on Google here. They like their recent Gemini release, which I'm sure a lot of you guys are familiar with. They report here that Gemini Ultra scores 90% on MMLU, whereas GPT-4, the best it scored was 86.4. And obviously that means that Gemini Ultra is better. Well, when you like peel back the covers a little bit, you look at what they mention here, which is chain of thought at 32 and 5-shot for GPT-4. And so what this means, chain of thought at 32, which is this first line here, it basically means they're doing chain of thought prompting and they're sampling 32 different answers for one given question and then taking the consensus among those 32 generated answers, which is a completely untraditional way to actually evaluate the MMLU benchmark. The typical way MMLU is evaluated is 5-shot prompting. So basically you include 5 example questions with answers in the prompt. And then the 6th one is just the next question and it has to get the right answer, which is like the commonly accepted way of doing things. And if you compare Gemini Pro to GPT-4 on the common way it's done, you actually see that GPT-4 outperforms Gemini Ultra. So not picking on Google here, but I kind of am. But this happens everywhere. This idea of like these are public benchmarks are very often reported with a lot of nuance that can skew the actual results. The second thing I would say about public benchmarks is like the results you get from them are wildly susceptible to small changes in the implementation of that benchmark. And I'll do a quick case study after this slide that goes in more in detail about what that means and sheds more light on it. The third piece here is like, in general, like these benchmarks give you like a high level indication of how well your model is performing in a broad set of areas, but it actually tells you nothing about how a given model is going to perform on your data set for your use case. So like it's a good high level pointer, but at the end of the day, like you still need to do further evaluation on your own data. And then I guess the last thing, which is kind of like a meta question, is like, well, if benchmarks are these publicly available data sets that are on the internet, and we have these models nowadays that are trained on the entire internet, are we implicitly overfitting our models to these data sets? Like, is there target leakage happening here? Is there any way we could even know that? And I guess the subset of that is like, are people just gaming these public leaderboards? Are they trying to just like get the highest score on the leaderboard by taking whatever method necessary, meaning that they're compromising the generalization of this model to use cases outside of that leaderboard, which is a good question to ask. Okay, how are we doing on time? Cool. So I guess, yeah, so a quick case study on MMLU. This is referring to point number 2 here. And the whole idea here is like, just to like highlight this idea of how finicky public benchmarks can be, or how nuanced they often are, is like the broad question, are we measuring what we think we are? And so last year, when the Falcon 40 billion parameter model came out, Thomas Wolfe, one of the founders of Hugging Face, tweeted, we have a new model that's topping the leaderboard. It actually overtaken the original Llama 165 billion parameter model on MMLU, or on all of the benchmarks. And quickly after that, you had people saying, hey, well, like, where do these numbers come from MMLU? They're actually quite different from what we reported in the paper. And so that's spurred this whole investigation of, okay, well, like, why are these evaluation benchmarks different when it's MMLU? It's the same benchmark. And so if you dive into it, it turns out there's actually like 3 different implementations of this same MMLU benchmark. There's one by the original authors of MMLU, people that built the benchmark. There's another one by this test suite, evaluation suite called Helm. And then there's another implementation by the Eleuther AI harness, which is what backs the OpenLLM leaderboard. And so the first area of differences is in how the prompts are actually formatted. And so you notice like this is the same question, but across all 3, there's different formatting. The first 2 have this little like preamble where it says the following are multiple choice questions, whereas the AI harness just simply prepends a question and choices, neither of which these 2 have the choices or question prompt, or I guess it has questions, but not choices. Then there's like small other things, like there's a line break here, just like things that seem trivial or should not be major issues, but as we'll see, like contribute to changes in outcome of evaluation performance. The second difference between them was how we actually sampled scores during the evaluation. And so if we think about like how do we actually run this evaluation? Well, we take the question prompt with the choices and we want to get out a correct answer. Take that prompt, put it through the language model. By default, what a language model outputs is a distribution across all of the entire vocabulary of the model. And that is a distribution of probabilities saying which token out of our entire vocabulary has the highest probability of being being selected as the next token to decode. And so in the original MMLU implementation, what they did was they took this probability distribution, filtered it to just get options A, B, C, or D, with the tokens for A, B, C, or D, because those are the choices that they wanted. And then of just those 4 tokens, they took just the one with the highest probability and said, okay, that's the answer the model predicted. Compare that against the ground truth. So that's the way the original authors did it. Helm, which is another test suite, their implementation of MMLU did something a little bit different, where rather than doing that step to filter out just to the tokens of A, B, C, D, they actually took the entire vocabulary distribution and just sampled which one, or selected which token had the highest probability overall. And so in this case, you end up with some answers where the model actually wants to output a token that isn't A, B, C, or D, meaning that you're going to have artificially, or potentially, not artificially, but you're going to have more incorrect answers, because there's chances where the model just doesn't pick up on the fact that it needs to output one of these 4 tokens and output something completely else. And so you're going to have different performance from that. And then finally, the Eleuther AI harness did things a completely different way, which was they actually looked at the combined probability of the entire answer along with the verbatim answer itself. So like not just the letter A, B, C, D, but they looked at the full probability of all the tokens in the answer and said, combined, which one has the highest probability? That is the one that they took for the answer that was predicted. And so you see that like it should be at a high level. It's like, oh, you just run this on MMLU and you get a score and we can trust it. But the reality is that like there are lots of little nuances to implementation that end up with wildly different results. So you see that Llama 65 billion goes from having a 64% score down to like a 48, just based on these differences in implementation. The moral of the story here is like, it's really important that we have standard evals, and you shouldn't just trust a number that somebody puts up on a screen. There's more to the equation. Okay, I'm going to move on to the next major way that things are evaluated, which is this idea of functional correctness. As I mentioned, kind of a subset of public benchmarks, but a little bit different. The functional correctness is this idea, like, can we use a functional test to validate or to explicitly determine if the output of our model is solving that task? And so the marquee use case or example here is in evaluating code generation models. So this benchmark, human eval, is 164 programming challenges, where basically for any one of them, you have the input or the prompt is a function definition, the type casing, and a doc string that describes what the function should do. And then the model is tasked with predicting the actual body of the function that solves this given description. And so just like with natural language generation, code generation, there can be multiple right answers. There can be multiple ways to solve to implement a given function. And so luckily what we have here, at least in the world of programming, is we have these unit tests where we can take the predicted function generation and actually execute it against some unit tests and see, is it passing the tests? Like, is it doing what we want it to do? And for this reason, this idea of functional correctness is actually like probably the best way you can possibly evaluate a generative model, because it directly measures the downstream task at hand. It directly measures the correctness of a model's generation. And so, yeah, like this is great. But one of the questions then is like, okay, well, does this apply anywhere else, or are we simply limited to just functional correctness for code generation tasks? And the answer is like, kind of, sort of. There are other ways to do this. So there's this, like, can we do this for natural language generation is the question. And so there's this benchmark called IF-eval, and they basically aimed to apply this idea of functional correctness to quantify how well models can follow instructions. So basically what they do is they come up with this set of like atomic, interpretable, measurable instructions that they can then run programs against to validate. So things like in your response, the word blank should appear n times. That's something that we can write a program to see how many times did the word blank appear. Or things like length constraints. So your response should have exactly this number of paragraphs. We can write a program to automatically check for that. Or things like you should have number of bullet points or a title or whatever it may be. Like there are certain types of things that we can introduce to get a more quantitative evaluation. And while they are limited relative to the general scope of all things you would want to evaluate in text and language generation, I would encourage you to try to weave these in if at all possible, because it is like the best way you can evaluate things, even though it's only like a subset of the things you might want to evaluate for. Hopefully that makes sense. The third method we have here is overall method is human evaluation. I think this is pretty straightforward, but a couple of considerations. The first idea of human evaluation is this idea of a vibe check, which is pretty popular and in my opinion for good reason. You can get a lot of value out of just manually interacting and probing a model to get a feel for how it answers and deals with certain types of questions. And so me personally, like I have this like a running list of like 3 to 5 standard questions. And it evolves over time as models get better, but I have like 3 to 5 standard questions that whenever a new model comes out that I want to play around with, I just ask it these questions and I interrogate it a little bit. And it's just it is like a great way to get a feel for how capable a model is. Obviously this doesn't scale and it's not very comprehensive, but nonetheless is a good first pass at feeling out a model's performance. And so like a one that we internally used to use quite a bit is asking an LLM how many helicopters can a human eat in one sitting. And for a while, even still today, I'm sure there's still models that would very confidently tell you that a healthy adult should consume no more than 1 helicopter per day, which obviously does not pass the vibe check. Human evaluation, I guess, just in a broader sense, is this idea of generating questions and then having a model or having human evaluators go through and use a set of criteria to like score the responses. You can crowdsource this in some cases, but the big consideration is like you need to attend to the level of expertise required to actually somebody's unmuted, I believe.
Ah bon? Ah,
yeah, the level of expertise, you need to attend to the level of expertise of the evaluator needed. So like if I'm evaluating LLM's outputs for like medical diagnoses, I better be sure that the people that are evaluating those diagnoses are capable or have the expertise to actually do a good job in doing so. And so for a lot of reasons, like human evaluation is slow, is expensive. People often think it's like the gold standard or the best, but the reality is that like it also is prone to bias. Humans have cultural differences. We have our own biases, and that leads to a wide variety and variation in actual scores. So it's a good method, but it's definitely not without fault by a lot of measures. And then the last area of human evaluation that I think is really strong, and this is the one that Andre Karpathy mentioned, is this idea of, or this example of LM-Sys's chatbot arena. If you guys haven't seen this, it's worth checking out. Basically what it is it's an arena where you pit models head-to-head battle style. So here we have like 2 anonymous models, model A and model B, and random users. Anybody can come in here and ask it a question. What's today's date? And we'll get responses from 2 different LLMs. And we have one of them telling me it's January 30th, which is correct, 2024. And the other one is telling me that it's January 23rd. In reality, a model shouldn't be able to tell me this unless it has access to the internet. So my guess is that this one is actually probably Gemini Pro. But what this allows me to do is like chat with a model, and then I can give feedback. I can say A is better or B was better, tie or both are bad. And here I'm going to say, okay, well, A was actually correct, so A is better. And now I see, yep, this is Bard Gemini Pro, and this one was DeepSeek LLM 67 billion chat. And what happens is like random users go in here and give their or interrogate the models, play with the models, and score them, and you end up with a leaderboard that gets these scorings called ELO ratings. And after sampling like across a diverse set of users, across a diverse set of like questions in the wild that people might actually be asking them, you build up scoring of like which model performs the best. And this is the reason why Andrej Karpathy, as well as a lot of people, say that this is like currently the best measure of how useful a model is. And that's because it evaluates a broader set of possible things you might want to measure than any one individual benchmark data set. So definitely check this out. I think this is super valuable. And it's what I use when along with vibe checks, this is another thing I pay attention to when I try to figure out which model is the best. Okay, we've got 10 minutes and I will speed through this. The last thing is model-based evaluation. Many of you have heard of this idea of LLM-as-a-Judge, the idea of using a model to evaluate the output of another model. It's a really powerful idea because of how flexible it can be. Basically, anything you can write a prompt for, you can evaluate for. So any of those criteria at the beginning that we talked about, like conciseness, faithfulness, truthfulness, like as long as you can write a prompt for it, you can evaluate for it. And so here you see like an example prompt that you might use to prompt GPT-4 to evaluate an output. You tell it to assess the feedback, to give me a score between 1 and 5. You provide it the instruction. You provide it the response that you want it to evaluate. You give it a reference answer, and you give it a scoring rubric that details out what each score should indicate. And there's a couple different ways you can do this. Like you can use LLM-as-a-Judge to do pairwise comparison. So similar to the chatbot arena, give an LLM 2 answers and say, hey, which one is better based on criteria. You can do it reference guided like this, where we give it a reference answer and we say, hey, evaluate this other one in comparison to this reference answer that we know is good. Or you could do it reference free. And there's been a bunch of studies that try to look at like how reliable is this? And in general, the consensus is like it's a pretty good method. Like it agrees in one study with GPT-4 achieves over an 80% agreement rate on par with that of human experts. There are alternatives to just using GPT-4. So the idea is like you should be using a really powerful model, a more powerful model to evaluate your model. But there are these open source models that are starting to pop up. And so in particular, we have like these 2 models, Prometheus and Judge LM, which are smaller open source models that have been fine-tuned specifically for the task of evaluating other models. And so in the case of Prometheus, what they found is like this column here is the overall correlation between an LLM's evaluation with human evaluation scores. You see that GPT 3.5 Turbo does a pretty poor job, has a low correlation. GPT-4 has an 88% correlation, while this 13 billion Prometheus fine-tuned model has an 89% correlation. And so there's different variants of different sizes. The good thing is that you can further fine-tune these models to evaluate things that you care about on your data set. It's an interesting field. I've heard good things and bad things. I've had some mixed results in my experience using these types of models as evaluators, but nonetheless, it's an interesting path forward. And of course, like none of this is without limitations. I guess like the major question that you think of here is like, all right, well, if LLMs need to be evaluated because they're unreliable, why should I trust an LLM to evaluate the other LLM? Which is a great question. Like it's kind of like the dog chasing its tail. Like what are we doing here? And I think it is a valid question, but there is value in this. The main thing being like you get really rapid iterations and you get feedback quickly, which is something you don't get with human evaluation. And so while there may be some issues and it may not be 100% perfect, if you can draw correlation with human performance, it gives you some confidence that you can use this as a way to rapidly move in the right direction. And I would also recommend like not using this just on its own. It should be LLM-as-a-Judge plus some human evaluation to help you iterate quickly while also having some like sanity check and level of confidence. Last thing I'll say here is like some of the known biases of using models to evaluate other models. Position bias. So LLMs tend to favor their responses that are in like the first position. So if you're doing multiple choice, they'll always pick option A or tend to pick option A more than other options. So shuffle your options is the answer there. Verbosity bias, LLMs tend to favor longer generations than more concise or short ones, which is an interesting artifact. And they also have the self-enhancement bias. So like GPT-4 will have a bias towards giving higher scores towards its own generated content. So the takeaway there is don't use GPT-4 to evaluate GPT-4. And then some other issues like LLMs struggle with continuous scoring. Like they're not as good at, they don't have as clear of an understanding of what it means to have this continuous range between 0 and 10. They actually do a lot better with assigning like a class label of like good, bad, or multi-class, like good, okay, bad. And the other limitation of this whole approach is like, if you see a correlation with human performance, so like people go in and say GPT-4 is correlated X%, 80% with human evaluation. That correlation was for what the data set and tasks that they evaluated on. That likely will not hold to what task you're using. So it's important to do your own human evaluation and your own correlation to LLM-as-a-Judge on your unique use cases. And I'll skip that for now. And that's about it. I have a slide here that gives a quick overview of the trade-offs between each. None are perfect. All have their benefits. And I think it highlights and points at how important this field is and how much rigor we still need to add to this field, this growing and important field of evaluation. So I would expect a lot of developments here in the coming months, and it's an important and, for me, interesting area to monitor. So with that, I see we have 5 minutes left. I will stop here to make sure that we can take at least a couple questions.